We're going to talk about logarithm. We are going to talk about how to solve for it. And also, for logarithm, we only have equation to solve, not really inequalities. Well, you might have inequality, but you can do it by sketching the graph. And same as polynomial inequality, you sketch for it, find the intersection, and then solve for it. I can give you one example later. But we basically focus on solve equations and sketching. So first of all, just quickly go through all these laws. I think those two, everyone know that's the rule, but when you use it, sometimes students get it wrong. So for example, we can't create like any new rules. All the rules is listed here. Anytime you want to do some like calculation, you must use those 1, 2, 3, 4, 5 rules. You can't use any other things. For example, the common mistake I can see is, for example, is log 3, 7 over log 3, 9. Let's not go 9, 10. For example, this one. A lot of students will, because of number division, you know, is the top one divided by the bottom one, and a lot of students will just do this. Unconsciously just doing this. It's wrong. It's wrong because we don't have this rule. Why? Because we don't have this rule. Also, if you put that back to exponential, it doesn't make sense. So everything, all the log rule is actually coming from exponential rule. I give all the proof below. So you don't need to memorize why, but like if you don't understand why the rule is like that, you can have a look at all those proofs. But like for example, this formula, it doesn't make sense. It's not the top number divided by the bottom number. When you have two logs divide each other, we don't have any rule for that. Well, we can use one rule. Which one we could use? We can use the change of base. We can use the change of base. Well, same base, one log divided by another log. When you have same base, you can use the change of base formula. So you can make that become log 10, 7. That's all right because we have that rule. Same base divided by same base, we can change it to one log. So that's something we can do. That's something we can do, but not that one. Not that one. Just remember, when you add to log, the inner number can be times together. When you subtract to log, the inner number can be divided together. That's the only way it should work. It's the only way it should work. So that's the first two, which will have like, do you remember when we have those two rules? We do differentiation. For differentiation, we use those two formulas to make our differentiation easier. Like when we have, for example, log e 2x squared plus 1x plus 5 divided by x minus 4. We separate that into two log and then differentiate that easily. So that's the first two. And the third one is very important. For most of the log, we also use this to do differentiation as well. We also use this one to do differentiation. We can bring the power into the front, become a constant, like a coefficient times by the log. This one is very common used. Well, for the fourth one, it's not really common use because it's not really a rule. It's the same as rule number 3. You can just bring the negative one into the front. It's exactly from law number 3. It's a special case. So, for example, log a third, that will equal to minus log a3. So that's how we use it. So basically, we check the power of negative 1 into the front. And log 5 is log any base of 1 will be 0. Log any base of itself will be 1. So these two special like evaluation point. A little bit extension. This extension is to when we do differentiation of exponential, but base is not e. I hope you can still remember that. When we deal with 2 to the power of x, we're trying to derive that. We need to change it to base e first. So the 2 will become e log e2. And then we differentiate that. So that extension there is to help us to do differentiation when you have exponential base is not e. That's the extension. And then the change of base. Well, change of base is differentiate log with base not e. Okay, so log 2x, we need to change it to log ex over log e2 and then differentiate that. So those two things is actually very helpful. Well, all of these rules is very helpful for us to derive exponential or logarithm, to make either easier or make it possible to derive. So change of bases, we can change to any base. Okay, we can change to any base, and then we put the base at the bottom. So log CB over log CA. All right, and well, forget about that one. We don't really need that one. I don't want you to remember some extra things. This is just year 11 for investigation. But we can remember this. Okay, this is very handy to use. Log AB will be 1 over log BA. So what we can do to prove this formula is, okay, log AB. We have base A here. You can see for the answer, we have B there. Okay, we have B there. So we need to use the change of base formula. We can change to any base, including the base itself and the number B there. So I change it to base B. So it's log BB over log BA. And log BB is just 1. So it's 1 over log BA. Okay, so that's how we prove it. We just use change of base formula to get this done. All right, and we keep going. So that's all the rules we have for log. So now let's think about evaluation. I have asked you to do this already, so we just check answers. So what we use is, well, you know, year 10 when you learn it, you make it equals to x, and then 3 to the power of x equals to 81. Well, it's all right. Okay, it's good. You can find the answer in the end, but it's a little bit too much to do. So we can use all the rules above. For example, 81 is 3 to the power 4. Okay, 81 is 3 to the power 4. And I can drag the 4 into the front. It's 4 log 3. And we have a 4. Law number 3 is the used the most. Okay, it's to be used the most. So we always get a power and drag the power into the front. So similarly here, that's log 3. We want the base 3 inside and to the power of minus 3. And we have minus 3 directly. We drag the minus 3 into the front, and log 3 is just 1. And the third one is the one I mentioned, like students will do, like get this wrong, like at the most. So we can't divide the 49 and 343. So what we should do, okay, well, we can use change of base, but there's no point to use change of base. Well, if we use change of base, that's log 343 and then 49. It doesn't really work. Okay, well, you can't use the one I crossed out to find the answer, but like, I don't want you to remember the extra thing. So we don't have that one. Don't do that. But what we can do is, okay, which one? Let's think about which one we can use. We can't use number 1, we can't use number 2, but we can use number 3 for top and bottom. So 49 is a 7 to the power of 2. 7 to the power of 2. 343 is 7 to the power of 3. Okay, so what we can do is 2 times log 7 over 3 times log 7. Well, log 7 is just the same thing on both top and bottom. You cross that out, and you have 2 over 3 here. Okay, and you have 2 over 3 here. Okay. Let's go to the next one. Well, But next one is add and subtract. Okay, add and subtract. But because we have the 2 there, well, we can put the 2 back because we have log plus log minus log. We don't have the coefficient into the front. So we can just get log 10 9 plus log 10 16 minus log 10 36 over 25. Okay, we square, we put the power, like we put the coefficient as the power. And then what we can do is log 10, 9 times 16, and divide by 36 over 25. Okay, you add is the same as times, you minus is the division. So that's log 10, 9 times 16 times 25 over 36. Okay, 9 and 36 becomes 4. 4 and 16 have another 4 here. So that gives you log 10 100. 100 is 10 to the power of 2. Well, 4 times 25 is 100, so that's 10 to the power of 2. And that gives you 2. Okay, and that gives you 2. Okay, for number 2, log 6 x to the power of 3 over 2, log 6 to power of root x. So I can do the same thing as the previous one. So that's 3. I can see, if I can see the power inside, I will just drag the power out. So that's a half log 6x. So log 6x and log 6x will get cancelled. And we can times 2 on both top and bottom. We get 3 here. Okay, get 3 here. Be very careful. Log divide log, you can't use the log 2. Okay, it's not log 2. So what we can do is drag the power into the front, or you use the change of base formula backwards. Okay, that's example 2 here. And for log solving, okay, log solving is very important. Okay, log solving normally will be put back into okay, log equation will normally put back as exponential equation. Okay, log will be converted back into exponential and then solve. Okay, log can be converted back into exponential and then solve. So for example, this one, we can put x to the power 4 equals to 256. Okay, x to the power 4 is 256. So x will be, okay, if you look at this equation, if you just look at, okay, forget about that. If you just look at x to the power 4 equals to 256, what you can do, okay, what you should do is plus minus root 256, right? Even power. Even power. Like if you forget the original question, you just solve x to the power 4 equals to 256. You will have plus minus. So your x solved out will be plus minus no, sorry, not square, like root 4. So you will have plus minus 4. Okay, 16 times 16. Yes, 256. So it's plus minus 4. But you need to check your answer. Okay, you need to check your answer back into the original log. Okay, for log equation, where I can write it. Okay, log equation. Answer needs to be checked. It's to be sub and checked. Okay, you need to sub your answer and then check your answer. Okay, every log equation, when you solve log, you need to put the answer back to check. Okay, you need to do that. So x can only be, well, what x belongs to? x belongs to r plus except 1, right? That's the base for the log. So x can only be positive 4. So x can only be positive 4. You can't have negative. Well, if you just look at this, yes, your x can be negative 4. Negative 4 to the power 4 will give you 256, but it not satisfy the original equation. So that's what I mean by you need to check and then decide or reject your answer. Okay, that's this one. The next one is x equals to 5 to the power half equals to x. So x is root 5. This one is nice and easy. We don't have multiple answers, and also root 5 is a positive number and then it's satisfied. Okay, next one. Well, when you see the coefficient, you would divide the coefficient. Log 2x equals to 4. Okay, I can make this thing as simple as possible. And then x equals to 2 to the power 4. And x is 16. And x is 16. Okay, go back to check. 16 is a positive number. Satisfy the domain of log, so it's alright. Okay, so it's alright. Okay, if I go back a little bit, okay, the domain, okay, so I write on the top, log AB. The requirement is A belongs to R plus except 1, and B needs to belongs to R plus. Okay, your base and the number you insert must be all greater than 0. But the base cannot be 1. Why the base cannot be 1? The reason is the same as why exponential space can't be 1. Okay, log is coming from exponential. Why exponential space can't be 1? Because it will give you a straight line. It's not really exponential. Same as log. If you put 1 there, it doesn't work. Okay, it doesn't work. So you must have all the positive numbers except 1. And what you put inside in the bracket, it can be 1. Because log A1 will be 0. So it can be 1. So it needs to be positive only. So that's the domain and requirement for the base. Okay, that's the domain and requirement for the base. And if you go to the next one here, example 4 here. So for example 4, can you see like it's log 2 minus log 2. So the first thing I would do is I need to combine into one log. Okay, when we solve log, we need to combine that into one log. So it's log 2 x plus 2 divided by x minus 1. And then we need to put that into exponential. 2x plus 1 over x minus 1 equals to 2 to the power 4. Equals to 2 to the power 4. So that is a 16. Okay, that is a 16. So we times the denominator on both sides. So 2x plus 1 equals to 16x minus 16. Okay, we times 16 times x minus 1 on both sides. I have 16x minus 16 on one side. We have 17 equals to 14x plus the 16 minus the 2x. 17 equals to 14x. And x equals to 17 over 14. X equals to 17 over 14. That's how you should solve for log. We first need to combine into one log and then convert into exponential form and then solve for it. Remember, we need to check your answer. Okay, check the answer. So how we should check it? We sub 17 over 4 into the original, the top equation. So it's a positive number. When you sub into 2x plus 1, it's still positive. When you sub into x minus 1, greater than 1, it's still positive, which satisfies the domain. So this is a good answer. Okay, this is a good answer. So we keep this answer. We have a solution for log. We need to check the answer every time when you solve for log function. Okay, that's important. It actually, in VC exam, there's part 1 exam, I can't remember which year, there's a question ask you to solve for log, and you need to check the answer to reject some values. So it's actually happened in the exam. Okay, if you can look at the next one. Okay, log 3x minus 1 plus log 3 x plus 1 equals to 1. So what I will do is I will combine that into one log first. When you add to log, it will be the same as your times them, okay, times the inside. So x minus 1 and x plus 1 will equals to 3 to the power of 1. Okay, 3 to the power of 1. Then x squared minus 1 will be 3. Okay, we expand it because right hand side is not 0, we need to expand. So x squared equals to 4. Question is, what x equals to? Plus minus 2. Okay, you must write plus minus 2 here because x squared equals to 4, x is plus minus 2. But remember, we need to check the answer. Okay, we need to check the answer. Let's check 2 first. Let's check 2 first. We put 2 in this, good. Put 2 in this, good. Okay, so 2 is a good value. Put negative 2 in it. Negative 2 in it. Negative 2 minus 1. Negative. Doesn't work. Okay, it doesn't work. Not satisfied. Minus 2 put in that, minus as well. Can't work. So reject x equals to minus 2. Well, due to domain. So x can only be positive 2. Okay, it needs to be plus, minus, and then check the plus, and then check the minus. You can't directly reject it. You need to give a reason why we reject it. When we solve x squared equals to 4, you must have plus minus 2 after that step. And then check, and then reject. Okay, that's like normal step. Okay, that's like a required step. You can't directly say, oh, x squared equals to 4, and I can see by my eyes negative 2 not going to work, and I directly give my answer as x equals to 2. You can't do that because you miss a value when you solve for x squared equals to 4. That's wrong. So it needs to give all the values which might be possible and check for it. So x can only be 2, not negative 2. Okay, can only be 2, not negative 2. Okay, there's this question here. And any questions so far? Okay, we basically learned how to solve log equations. Okay, that's how we solve for log equations. Please go to page 9. We have example 2 here. Okay, for this question, I want to solve for the value of k. Okay, I want to solve the value k. So k is a constant. Okay, k is a constant. So what I can do is, okay, so k log 2 3 equals to log 2 6 minus 1. When you minus 1 is log 2, right? Minus 1, the 1 is log 2. Why I make it log 2? Base is 2. So I will make log 2. So k log 2 3 equals to log 2. 6 divided by 2. When you subtract to log, you will divide the number. Okay, so divide the number. K log 2 3 equals to log 2 3. Therefore k is 1. Therefore k is 1. So divide log 2 3 on both sides, you have 1. So So it's the same as how you solve for other values. You want one log, okay? You want to combine all the things together as log. The constant, you make it into log. And then we combine them, we divide by the coefficient. Okay, if I change the question a little bit here, can still keep the same as what we have. Log to 6 equals to k log to 4 plus 1. I just changed the log to 3 into log to 4. Let's see what we can do. Well, again, k log to 4 equals to log to 6 minus log to 2, which is minus 1. So k log to 4 equals to log to 3. Okay, 6 divided by 2, we have 3. So k equals to log to 3 divided by log to 4. You can either keep the answer like this, okay, it's exact. Or you can use, well, when two log divide each other, you can use the change of base formula to make that back into one log. So the bottom one is the base, so it's log 4, 3. Okay, it's log 4, 3. So that's what we can do, yeah. You can do that as well, like for example this one, talk about that. So that can become 2, right. You can make that in, shouldn't put 4. I want to use the change of base formula. Yeah, you can just directly divide by 2 and say that's a half of that as well. Okay, that's alright. Well, if I want to use the change of base formula, you are correct. Maybe change to a better number 5. Well, you don't need to change it as long as you understand it. So that's a 5, and that's a 5. So it's log to 3 divided by log to 5, and then I can make it log 5, 3. And Shreya's correct. If it's log 2, 4, I can make it into 2 and then just divide by 2. Okay, so that's log solving. So basically we only have equation solving. Okay, equation solving. I will save the video first.